Welcome back to the vlogs.
Hi guys, welcome back to the vlogs.
Okay, 12.5 KYS. Okay, 12.5 is conditional probability. Conditional probability. The last lesson of, what is the last lesson?
Here, guys. Wow. Enjoy it.
Okay, conditional probability. Conditional probability says the probability of an event can change. That means it's conditional, okay? It can change. If we know that some other event has occurred, this idea is the key to many applications of probability. The conditional probability reflects how the probability of an event can change. If we know that some other event has already occurred, okay? When the probability of A is greater than 0, the conditional probability of B given A is that the probability of B of A equals the probability of A and B over the probability of A. What does the probability of A and B mean that we're doing? Multiplying, and then we're dividing it by the probability of what we're not looking for. Does that make sense? Okay, so my conditional probability is saying probability of this happening together depends on what happens here. Okay, so and the probability of B over A is showing me B divided by A basically, and the other probability tells me it's the probability of A and B together divided by the probability of A, because it is conditional upon what is happening with A. If A and B are independent events, then the probability of A of B just equals the probability of A, and if it's independent, the probability of B of A just equals the probability of B. So where they're independent, they just equal whatever is listed first. So independent looks like this. It says probability of A of B equals the probability of A. Probability of B of A would just simply equal the probability of B when they're independent. Conditional probability, they're dependent upon each other. Okay? Give you a second and then we'll go. There's only 4 slides on this one today. Okay. Like I said, you have to know what all these symbols mean in order to know what you're doing. Because we're skipping the Bayes theorem today. We're not going to talk about.
Doug?
Yeah, about Doug, sorry.
I love you, Doug.
Wait, what?
Doug's theorem, the Bayes theorem.
Gang.
Doug Rakes.
Okay.
Doug said that's a wreck.
Earlier we did.
Yeah.
What?
In the diagram, the numbers represent the number of events, okay? The conditional probability of occurring given that B has occurred. Okay? So in the diagram, the numbers represent the number of events. The conditional probability of A occurring given that B has occurred. They want us to find the conditional probability of A occurring given that B has occurred. That means, okay, how would I set that up? They want what? What are they asking when they say the conditional probability of A occurring that B has occurred? Probability of what? A. So then it equals what? The probability of A and B over what?
The probability of A.
Over the probability of B.
Oh, B, C, C.
Okay, B's on the division side. B goes. Okay, so how can we figure out the probability of A and B? Look at that diagram. The numbers tell me everything I need to know. What? What do you mean, doesn't it give it to you? Not necessarily. Your probability should come out as a decimal, not a whole number. What's the total for events A happening? What's the total amount for events. No, for everything, what's the total amount of events? 15. 8, 5, and 2 is 15. So it's out of 15 total. What's the probability of A happening?
5.
Let's talk about, is it 7 or is it 5 out of 15?
It's 5 because
It's just 5
2
because
is
it's just the
included in-
independent probability of A, right?
Because yesterday the
Let's work it,
number.
we'll see, we'll work it both ways and see. So if I decide A is 5 out of 15, okay, we're gonna work it here. And if I decide A is 7 out of 15, let's see which one works. What would be the probability of B then?
Well, it could be A over 15 or 10 over 15. That's what we're going with.
Listen, let's be a little smarter here. Let's use some common sense. This right here says probability of A and B, correct?
Yes.
What's the probability of A and B?
A.
No.
The probability of A is.
Okay, you keep saying, I need to multiply. I don't need to multiply on this because I can look at the picture and it tells me what the probability of A and B are.
7.
No. 2 over 15, thank you. Because 2 is where A and B overlap. You don't have to do any math on this one.
Oops.
The probability of A and B is 2 over 15. You take 2 over the whole, okay?
My fault.
That way we can use some common sense there. Even though I know this is multiplication, because of the diagram, I don't have to multiply. They gave it to me. It's 2 over 15, okay? What's the probability of B? No, not 8 over 15. How much stuff is total in B? 10. It's 10 over 15. It's 10 over 15, okay? So I have 2 over 15 divided by 10 over 15. Here's how we have to think. How do you get a fraction out of the bottom of a fraction? Multiply by the reciprocal. Beautiful. So I multiply the top and bottom by 15 over 10, yes? This cancels, yeah?
30 over 150.
2 times 15 gives me,
30 over 150.
and what's 15 times 10? 150. What's that reduced down to?
1/5.
1/5, which is 0.2.
Good job, Kaden.
Thank you.
You're welcome.
That's your answer. So the conditional probability of A occurring, given that B has occurred, is a 1/5 chance. Okay? Don't make it harder than it is. Look at the picture and use the little pretty picture. Okay? If it was very simple, you don't have to do more math than you needed to. Okay? You can do this. Okay. You roll 2 dice, a blue die and a red die. What's the probability that the red die comes up 3 if you roll an 8? How can I figure that out? You roll 2 dice, a blue die and a red die. What is the probability that the red die comes up 3 if you roll an 8?
The total is 8?
Yes.
Oh, okay.
So you roll 2 dice, a blue die and a red, okay? So I'm gonna say red and blue. This is gonna be probability of red, probability of blue, yes? Okay. So you roll 2 dice, a blue die and a red die. What's the probability that the red die comes up 3 if you roll an 8? How do you figure that out? What relies on the other? No. Three relies on 8 because your total is 8. So 3 relies on that. So my total is 8. So my probability of my B, in this case, okay, is not about my blue dice, it's about my total. My probability of R is my red die. I'm looking for my red die, but it's reliant upon my total. So my total is what? 8. What do I need my red probability to be? What does my red die number need to be? 3. okay? So my red needs to be 3, my total is 8, okay? 3 relies on the 8, okay? One of the numbers has to be 3, so it relies on the 8. So the probability of A over B equals, okay? Probability of A over B equals what? So what is A and B? Because, right, this top part is probability of A and B. What's the probability of rolling an 8 when you're rolling 2 die?
Like the total?
What?
You're talking about the total or the number?
Be some with 2 die or 1 die.
Okay, listen, with 2 die, but you have to think this through. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right?
Over 8 is an add.
But listen, this is red. This is blue. So you need a 3 to make up the probability of, you need a 3 in red to make an 8 for that to be your probability. Does that make sense? So, what's the probability? We can do it one of 2 ways. We can do it chart or we can do it by multiplying. What's the probability of rolling a 3 in red? 1 out of what?
6.
6, right? 1 out of 6. Now, let's double check everything. This is 2, this is 3, this is 4, 5, 6, 7, right? So if I roll a 3 and a 1, there's no 8 there, correct? Okay? 4, 5, 6, 7, 8, 9.
No,
3, 4.
this is really not your day today.
Okay. So I have this. So look, when I roll a 3, I have a probability of rolling an 8 how many times?
1,
Once out of
3,
how many?
3.
No. Out of 36. Because there are 2 die. 2 die means I have 36 options. Okay? So the probability of A and B happening, rolling a red 3 and it comes out as a total 8 is only 1 out of 36 times. That's what goes here. 1 out of 36. What is it being divided by? How do we figure out the probability of B? The probability of B is getting a total of what number? 8. So, how many 8s are there? 5 out of 36. How do you get rid of that fraction? Multiply by the reciprocal of 36 over 5. 36 over 5. Look at this. 5, 5, 36, 36. Oh, what happens?
1, 5.
Which is what percent? 0.2.
Well,
Or 20%, 0.2. Okay. That is how you have to start thinking through these. Okay? Korea's not liking this.
No, because I just came from chemistry.
Because you keep wanting to say 1 out of 6 and 1 out of whatever, right?
yeah.
Yeah, doesn't work that way. That's the problem. Okay? If a player is a pitcher, the probability that he is left-handed is 40%. 32% of players on a team are pitchers. What's the percent, what percent are left-handed pitchers? How can I figure that out? I have the probability of A upon B. Let's give A and B a name. What would A be set equal to in this case? What do you want to name A? What are we trying to find? Okay, so your A is always what you're trying to find. So we're trying to figure out left-handed, okay? My B should then be what? What should my B always be? Yeah, your total, so total pitchers, right, being a pitcher, okay? In this case, my B is pitchers. Now, let's figure this out. This is probability of A and B, right? Over the probability of B. Okay. What is the probability of A and B? What do I need to do? What is the probability of being a left-handed pitcher? It tells you right in the instructions.
40%.
40%. So if a player is a pitcher, the probability he's left-handed, meaning a left-handed pitcher, is 40%. So 0.4. That is A and B together. Do you see how I'm not really doing any math in any of these? I'm literally reading the problem and plugging stuff in. Okay? So this is represented by 0.4. Okay? 0.4. Now, after that, it wants to know what is the probability. So the probability of a left-handed pitcher is 0.4. Okay? That is just in baseball in general. However, you have to take into consideration the percentage of players on a team that are pitchers. How many percentage of, what is the percentage of players on a team that are pitchers? Point, what? Yeah, 32%, so 0.32, right? Okay, so I do have to multiply 0.4 and 0.32 together to get that top portion. Because I need left-handed pitchers and I need, because it's a percent of a total, I have to multiply by that percent of the total. So 0.4 times 0.32, okay? Which we'll figure out in a second. Now, what's the probability of being a pitcher? It's one of the numbers we already used. Yep. So 0.32. That's how I set it up. Probability of A, left-handed, probability of B, number of pitchers on a team, the percent of pitchers on a team, divided by the percent of pitchers on a team. So, what's 0.4 times 0.32? .128. 0.128. What's 0.128 divided by 0.32? 0.4. That's ironic. So what is the percent? Okay, so it's 0.4, right? So professional baseball teams have 25 players, so that means about how many players would be pitchers? 25.
It's 40% of 25.
So about 10 of the pitchers on a roster of 25 would be pitchers. What, does that logically make sense?
I told you I was 4.
You would?
I told you I was 4.
But does that logically make sense? Think about pitching and think about baseball.
Yes.
Yeah, it does, because in softball, you can use the same pitcher all the time, yes, like, for the most part. But in baseball, you have a rotation that you go through. And think about this, once you get to higher up baseball, like professional and college, they have people that are just closers, people that are just openers, and all have to be on a rotation. Okay, because you only pitch, what, once every 3 or 4 days, 5 days?
If you're a starter.
That's why you have to have so many. How many games do you have in professional? Like 100?
162.
Yeah, that's why you have to have so many. Your roster is literally filled with pitchers. Okay? Okay, here's what you do. Your homework is page 619, 1 through 31 on. Anytime it talks about the Bayes theorem, you don't need to do those
Yeah,
problems.
we don't like does.
If it does show up. I tried to avoid them, but I could be wrong in what I did, so. Kayla, let's go.
Like, subscribe, comment, tweet me at David Dobrik. Anything else to add, Korea?
I wanna go home.